Hi, my name's Tony Ross. I'm a program manager for Internet Explorer. I've worked on a number of HTML5 features recently for IE. For IE10, I've worked on the HTML5 parser, the HTML5 history APIs, and the HTML5 async support for script elements. Today I'm here to talk to you about the anatomy of HTML5 applications, or to look at it another way, kind of the fundamentals of how advanced HTML5 apps are built and the basic techniques you need to know to build some of your own. To do this, I'm going to start by talking a little bit about what you can do with HTML5, and then I'm going to get into a few of these techniques, namely being able to update and change content on the fly, being able to fetch data behind the scenes, and some techniques for keeping your code in check as the size of your code base grows. First, there's a lot of things you can do with HTML5 today. It's a lot richer than HTML of the past. You can do everything from playing media with audio and video, drawing using Canvas, advanced layouts with CSS, even loading and saving files with File API. And there's much, much more beyond this. But one of the new things that you can do with HTML5 is use it to build Metro-style apps for Windows 8. Now, on that note, I want to show you a few examples of what HTML5 can do. So I'm going to switch over here. What I have here is more of your traditional... Actually, we'll start over here. Here we go. What I have here is a little bit of a game built using SVG in HTML5. It's something you might traditionally expect to see being done in Flash, but this is actually all done with HTML, JavaScript, and CSS. Another example that I have is kind of a rich photo experience, which starts by looking a little bit like a traditional layout, but using CSS transforms and some animation, you can spruce it up and give your users a more compelling experience. Lastly, I have this fishbowl demo, and what's interesting about this is it demonstrates some of the composition capabilities you can get with HTML5. Specifically, I have a video that's actually playing as the background for this fishbowl, but you can use clipping and stuff to make it really feel like part of the app. All right, let's take a step back and look at the basic structure that underpins some of these HTML5 applications. Sites and apps generally have the same underlying HTML in the sense that you have an HTML5 doc type, which triggers standards mode in all browsers. Then you have your overall structure with your HTML head and body elements. You'll have your links to your external CSS files placed in the head, and then your links to your external script files placed in the body. And then your content goes before the script in the body. Now, looking at CSS itself, it's generally a collection of rules. You have selectors that can target things with tag names, class names using the dot syntax, and IDs using the pound sign. Then in each side of these blocks, you have properties that are going to apply to the set of matched elements. For example, I've said for buttons here, I want them to have a particular color and padding. Now, the bulk of what's behind any of your HTML5 applications is JavaScript. Now, I'm not going to go into great depth on JavaScript, the language, because that's a huge topic, and I have some references at the end that can help here. But the fundamentals are you can declare variables using the var keyword. It has a nice object literal syntax where you can define an object with multiple properties straight up using colons as the assignment character. And you can assign properties later on just using assignment using the dot syntax. Then functions can be declared using the function keyword. You just have to name your parameters because there's no typing, and you can return whatever you want. An interesting note about functions is that they are actually objects in JavaScript, so you can pass them around as parameters to other functions or return values, store them in variables, etc. Lastly, just a straightforward syntax to call functions. Now, one of the things that's common to nearly all HTML5 apps is that they're navigation free. What I mean by this is they're a bit more than just a collection of little blue links. Normally, they're not taking users between multiple different pages, but keeping them in one spot and refreshing content as you go. One of the key fundamentals of this is being able to update and change your content on the fly. I'm going to start by showing you how to locate elements, because if you can't find elements on the page, you can't change them. One of the easiest ways to do this is using the selectors API, or query selector in query selector all. For example, if we have some HTML where we've defined classes, in this case tab, from CSS we'd use the dot syntax to reference those and say customize their border radius. From JavaScript we'd use query selector all to get the entire collection of all elements that have the tab class. Once I've done that, I can do additional work on them, such as listen for the user to click on a tab in order to call a function. Now this is a good time to step aside and talk a little bit about registering for events, like I did for click in the previous example. So on click and on star, really, it could be on mouse over, and a variety of different events that you can listen for on elements, including key presses and more. There's a simple registration mechanism you can use with the on syntax. You can also use add event listener, which gives you a few more configuration parameters. Next, let's talk about actually updating the text of an element that you've selected. The simplest way to do this is using text content. Now, I'm using selectors API again. This time I'm targeting something by ID, the title, and in the CSS you see I have the pound sign to indicate it's an ID, and then I'm using query selector to just select a single element, my title element that I want to work with. Then I have a function that when it's called, I'll take whatever text was provided and I'll assign it to the text content of the title element, therefore updating the title on the page. In addition to changing the text that's inside of an element, you'll probably want to add and remove and move around elements in the page. For example, if we want to create the HTML we see here where we have an image within our body, we could create a simple add image function that calls create element, simply passing in the name of the tag that you want to create, image in this case. You can perform whatever other configuration you need, and then you can append it to another element, in this case the body. Now once you have the various different elements you want in your page, you're probably going to have various pieces of content you don't all want visible at the same time, but you want to show and hide them in response to user events. The simplest way to show and hide things is using the display property. This is something that sits off of the style object of an element, so you can just access it and change it using style.display. In this case, if you want to hide it, you use display equal to none. So I have a swap API here that I can use to switch between two of my conceptual pages in my app. And then to show one, or really revert it back to its default state, I can set display to the empty string. Let's go take a look at how some of this works in action. So what I have here is more of the traditional static site, as I mentioned, the collection of little blue links. If you see the address bar as I'm clicking through here, I actually have 5 different pages to show these different previews of different images. What I want to do is take this and make it a bit more dynamic, so I'm not always going back to the server. So I've pre-made a dynamic app here, and as I click through, you see the overall behavior is the same, although it's a little snappier, but my address bar isn't updating. So let's see a little bit about what this is going on here. If we look into the source code, we'll see that we've actually loaded all of our tabs up front, and then we have the content of all the pages up front as well. Now in our script that we've created, we'll initialize these pages, we hold on to the collections, and then you'll see we actually have the swap API we talked about earlier. So each time I click on one of the tabs, I'll call swap, and we'll switch out whatever the current view is and show the new one. Okay, so that's how you can have a whole bunch of data in your page and be able to make some changes, dynamic updates. But what if you don't want to have it all up front? You want to pull some stuff down from the server dynamically, but you still don't want to force the user to leave the page. Well, this is where we need to talk about fetching some data behind the scenes. The most fundamental way of doing this is using XML HTTP request. So what I've done here is I've created a little bit of a abstraction layer that we could reuse with a load API where I want to provide an URL, some data I'm going to send to the server, and then a function that I want to be called back when I get my response from the server. To create XML HTTP request, I just use new XML HTTP request. I use the open API to provide whatever HTTP method I want, in this case get, provide my URL. Then I can register for an event onLoad, in this case, to know when the request is loaded. I'm also passing what's called an anonymous function in JavaScript because you don't have to name them. As I mentioned before, functions are objects in JavaScript, so I can declare them on the fly and add them as the listener for this event. And then to actually send my request, I call the send API and provide my data. Lastly, when onLoad fires, I get to run my function, and I can access the response through xhr.responseText, which I'll pass on to my callback function. Now this is great, but it only allows me to pass strings back and forth between my server. Often I'm going to have much more complex information, and it'd be great if I could pass full-fledged JavaScript objects back and forth. Well, in fact, I can using the JSON APIs, json.parse and json.stringify. So what I have here is an example slightly modified where I've created a load JSON example instead of just a load. The intent is that I would provide a JavaScript object as the data and then provide the JavaScript object from the response back to the callback. All I really had to do differently was when I get the text from the server, I call json.parse. It creates a JavaScript object for me that I can send back. And then when I'm actually sending my data, I stringify it to a JSON string before sending it to the server. When I actually call my API, I can pass in JavaScript objects. In this case, I'm using the object literal that I mentioned before. And then my response comes back. It's a full-fledged object that I can access properties off of. So I don't have to worry about doing my own parsing and serialization of the strings. So let's take a look at how this works with our original demo. We'll go from our dynamic app. We'll actually take this to be a fetch-based app. Open up my tools here so we can take a look. Now the functionality here is still mostly the same, but there's a key difference behind the scenes. When we look at the HTML, we'll see that the pages and tabs aren't actually in the HTML we sent over the wire. What happened is they were requested later on using XML HTTP request. So I go back to the summary view, you can see there was a JSON file that was pulled over the wire, and this actually lists out all the thumbnails and images that I want to load and flip between. And that's really the fundamental change we made. And this gives me the flexibility to do things like potentially add a search in the future or do any other sort of thing where I want to use the same fundamental display but change the content by querying the server. All right, now that we've got the fundamentals in place, I want to talk a little bit about some techniques you can use to keep your code in check as you add more and more capabilities to your HTML5 apps. One of the key things here you might run into is that in JavaScript, everything's in the global scope by default. And you don't want to keep creating more complex function and variable names to keep everything from colliding. Fortunately, you can use a technique called the module pattern to isolate related pieces of JavaScript so that they can only see each other. This takes advantage of kind of the anonymous functions that I talked about earlier. In this case, we're wrapping the related code in an anonymous function that we're invoking immediately. Because in JavaScript, all variables are scope to functions, this creates a scope where we can store variables that won't get exposed into the global scope. So I can still call my setTitle API internally, however, since I defined it in the same scope. Now that's great, but you're likely going to have various different APIs that you want to share between modules. So while you want to hide a lot of this within a module, you're probably still going to want to poke some holes so certain APIs are available publicly. You can do this by actually returning an object from your wrapper function. In this case, I'm taking my setTitle API, and in the object, I'm storing a reference to it, using the same name setTitle. That returned object then gets stored in my module variable that's global. Therefore, any other module or other global code can access that using module.setTitle to still set a custom title on my page. Let's take one more look at how this might look within our simple application. This time, there's not really as much of a functionality update, but just a little bit of code reorganization. If we go over to the script file, we'll see now that we've hidden a lot of our implementation inside of using the module pattern so that it doesn't bleed into the global scope. And then we've even created a little photos module for loading our photos from the server. That way I can hide the details of how it's actually pulled out, but expose an API that I can use to load the photos, which I then call later on in my init method. So that's really the basics of what I have to talk about today. The key takeaways for you are to remember that you can use HTML5 to build Metro-style apps for Windows 8. To keep your HTML5 apps navigation free, be sure to use XML HTTP requests and the JSON APIs to send complex JavaScript objects back and forth between client and server. And as your JavaScript grows, remember to organize it using the module pattern. Now we have a number of other HTML5, CSS3, and JavaScript-related sessions available, and I encourage you to look through them and take a look. You can go a lot deeper on a number of different topics. Also, if you'd like to go deeper on JavaScript the language, I encourage you to take a look at Luke Hoban's talk from Mix of this year. Finally, if you'd like to see more examples of what can be built using HTML5, check out ietestdrive.com or beautyoftheweb.com. Thank you.